Hello, this is Dr. Raz. In this video, I would like to show you how to do hypothesis testing for proportions, specifically for two samples. To be able to do the illustration, go to our class Blackboard, find 2.8 hypothesis testing for population proportions, and then scroll down and find 19 career fair pizza hypothesis test Excel data. Three dots, download the original file, and then open that file. And once you open the file, enable editing, then you can see data here. The first column is A and B. I have, as you can see, 380 entries. A means the no pizza event. B means the event with a pizza. And then you can see the entries here that attended or not attended. One represents people attended versus zero represents people did not attend. So you can see the test calculation. First of all, I would like to start with number of people invited with no pizza. It's equal to count if. And I will go to A, boom, and then I will lock this function F4 and comma. If it's equal to A, then I will count it. Perfect. And I will drag this one to the right to copy the formula for B as well, but instead of A here, I will replace the A with B. Okay, 180 people with pizza, 200 people with no pizza invited. And now I would like to calculate the how many of those people attended out of 200. So I will use count ifs instead of ifs because I will check to see whether it's no pizza situation and also whether it's that person attended. So I'll go to the data and column A, and again I would like to lock this function F4, comma, and then I would like to make sure that it's A first, comma, and then I will go back to my data and then column B. Again, I will highlight it and then function F4 to lock it, and then comma 1, which means attended. Okay, so you can see 50 people without pizza, they attended. And then you can do the same thing, drag it, and just change here A to B, and 72 people here attended. So I can calculate proportions. 50 people attended out of 200, that's 25%. I can drag it to the right, and 40% for with pizza. So you can see the increase 15%. Is this increase just a random increase, or is it significant increase due to change in pizza serving situation? To answer that, I will do here hypothesis testing, and to be able to do that, I will use z-test. But to be able to do that, I will look at first pooled proportions, which means I will look at people who are attended total, which is 122, divided by people who are invited total, which is 380. The population for these two uh, is 32% attendance. So now I will calculate standard error, which you can see the formula for standard error here. That is probability of success, 32%, times 1 minus probability of success. And then you multiply that by 1 over invited sample size plus 1 over 180 sample size for B. So intuition of this is if the probability of attended versus not attended is very close to each other, which means close to 50%, 50%, you get the highest number here that will increase standard error. If the probability of attended is significantly high or lower than the not attended situation, then this number will shrink. That means the standard error will be less. Also, if I increase sample size for either or, for A and B events, I can decrease my standard error because I have more data points. Okay, so let's do this calculation. Square root of this times 1 minus that times 1 over 200 plus 1 over 180. Okay, perfect. So you can see that almost 5% is standard error, which is based on if the null hypothesis is correct, I do anticipate that much variation to happen, which is part of my standard error of difference. Now I would like to calculate the z statistic uh, based on the value. So basically, the difference between pizza probability, attendance probability, which is 40%, minus no pizza attendance probability, which is 25%. The difference is 15%, is relative to standard error is 3.127 times. Okay. And actually, if you wanna, I think it's better to just put first the current situation, which is no pizza event minus pizza event. Instead, the no pizza events, you can see three standard error on the left of the pizza event. Now I can calculate the p-value using standard normal distribution, norm.s.dist. And here my z value is right here. And then I want to do cumulative probabilities because this is a continuous distribution. And that is 0.01%. But since I'm checking to see whether they are equal or not, that means that I need to check both tails. It's not like one of them is greater than or worse than other. So I will multiply by 2 because I have two tails. Okay, so that p-value is 0.02, which is much less than our alpha significance level that we chose before even we started our analysis. So the decision we make here is that if this value is less than the significance level, then reject the null hypothesis. Otherwise, don't reject the null hypothesis. So in here, we reject null hypothesis that that they are the same. So I collected enough evidence to show that I can reject this equality. However, we don't say that we prove that it's not correct. We just say we have enough evidence to reject this null hypothesis. Also, we can say our data suggests that the average probabilities, pizza or no pizza situation, suggest the keyword that they are not the same. Okay, that's it for this video. Until next video, enjoy business analytics.